Welcome, everybody, and thank you for being here at our presentation for leveraging data at scale for data-driven development. My name is Masoud Afshar, and I'm a senior data engineer for iteratec. And this presentation was actually intended to be a joint effort of Deutsche Bahn and iteratec. Unfortunately, the representative of Deutsche Bahn couldn't make it today here to the stage. Please don't believe any rumor. Yeah, it's because his train got delayed. It's definitely fake news. He actually fell ill, and I volunteered as his substitute today. But it was all on very short notice, so please bear with me if I'm not always up to scratch on everything on the slides, or if I have to be a bit hazy on the details. All right. But first, let's talk a bit about Deutsche Bahn. I think the company itself doesn't need much introduction, as it is the national railway company of Germany. And you might be also familiar with its mission statement. So its long-term strategy is called Strong Rail, or in German, starke Schiene. And one of its goals is actually to double the amount of long-distance passengers to over 260 million passengers in the next 10 years or so. So with such an ambitious goal, it's worth taking a look at its mobility platform, which is actually one of the most successful mobility platforms in Germany. Its core applications are DB Navigator and the Bahn.de, which I think most people should also in Germany be familiar with, because you either have it installed on your mobile phone or you have accessed it through your browser, if you have ever booked a ticket digitally with Deutsche Bahn. Through these two applications alone, actually, Deutsche Bahn sells more than 100 million tickets per year, which can be broken down to up to 1 million ticket sales per day. As you can imagine, this, of course, generates a lot of online traffic with about 1,000 travel information requests per second. So, with these numbers in mind, DB Vertrieb actually decided to build a big data platform as an integrated component. And this is what we want to talk here and present to you today. So what are the goals of such a big data platform? What would it be used for? The idea is to add value to the entire life cycle of digital services, which we here have broken down into 3 stages, like ideation, exploration, integration and deployment, and operations. In the ideation process, it would help Deutsche Bahn actually to understand the current usage of services and channels, and thus help to prioritize new features and optimization efforts. As for integration and deployment, it is an enabler for new data-driven smart decisions, so that you can make smarter decisions based on the company development, business operations, and so forth. Finally, it also helps with operational aspects. For example, with anomaly detection, or the integration of technical data into the data platform itself. The data provided by the data platform will help to keep current applications like DB Navigator and Bahn.de stable and running. So, as with every project, it comes, of course, with challenges. And what I want to make you aware of, particularly, this big data platform that we are talking about was implemented as a data lake. And it was actually the first one at Deutsche Bahn. So it is now running in production for about 5 years. And many things that we achieved there are actually considered pioneer work and laid ground to be a blueprint for other data lakes within Deutsche Bahn. So what are some of the challenges? Of course, first you have to get the data into the data lake. And preferably this happens in real time. So our approach was, of course, to connect other development teams directly so that they can send their data into the data lake. And we did this by custom libraries and connectors that the development teams could just take and then integrate into their own product. And this way, we would always get all relevant data directly into us. It helped, of course, ease the process of integration, but also fostered, of course, the acceptance of this data lake. Closely related to this, as we not only want to get the data in real time into the data lake, but of course, we also have consumers that want to have the data as soon as possible ready to make their analysis. So to meet this requirement, we also went with a event-driven streaming approach from the get-go, so that we always have the data available as soon as possible for everybody. During data ingestion, you always have to make sure that your data meets all quality standards, which sometimes have even conflicting requirements. So our approach and solution here was to enable the business experts directly on the platform to configure each rule so that the data is always up to scratch and meets all necessary requirements. The data that we serve in many cases has to be highly processed. So you will get many interdependencies from data sources, transformations A to B, C, and so forth, until the final product that we want to deliver to the customers. Of course, this also must be reflected in all the surrounding systems, and this is also, of course, one of the big efforts to build a smart scheduling system for this, so that it can reflect this complexity. Finally, we have to make sure that the right data gets to the right customer in the right way. So we always have to make sure that we are able to make custom tailored data products so that we can always serve many different use cases. These are broadly some of the challenges that I wanted to present to you. But in the second part, we will actually make a bigger dive into the architecture. So how is this data lake actually implemented technically? And three of the most interesting will be presented to you now by my colleague, Simon.
Thank you, Masoud. And thanks again for doing this on such short notice. So we asked him Monday evening. So my name is Simon Hampe. I'm a data architect at iteratec, and I'll be talking a bit about the more technical side of the project. But don't worry, it won't get too nerdy. I'll start with a very short introduction of iteratec. Then I'll discuss our architecture and recap three of the key challenges that Masoud just showed us. And then I'll go over each of these in turn and sketch our solutions. So first of all, who is iteratec? So this is the 2-minute ad break in the talk, basically. So we are an IT company rooted in creating custom software, but we offer services in all stages of digitalization, and we call these stages create, code, care, and coach. Create means we help with ideation, hold workshops, or we tap our experts in key areas such as, for example, security, application performance management, blockchain, or data. Code is our core business still. We build software on a variety of platforms and providers, be it mobile apps, web apps, classic full stack development, or data platforms. Care doesn't only mean like day-to-day maintenance, it can also mean improving existing software, for example, through application performance measurements, security audits, and the like. In terms of coaching, of course, we coach customers on the software that we write for them, but we also have more general trainings, for example, through our agile coaches. We are more than 500 people if you count our students. We've been around for a bit. We turned 27 in June, nearly 60 million euros turnover, and we have 7 branches, most of which are in Germany, but we have 1 branch in Austria and Poland each. So what's our role in this project? Well, as I said, our core strength is creating custom software for custom problems. That's precisely what we did. So let me show you how. Ad break over. So this is a very high-level sketch of our architecture, and it will seem fairly standard to anyone who's familiar with data architectures at first glance. So first of all, we have our data sources. Most of them are streaming, as Masoud already said, and we get about 100 gigabytes or 100 million events per day. And they are then passed into a data ingestion layer. And in this data ingestion layer, we make sure that the data meets all the necessary quality requirements. We check metadata requirements, data protection requirements, and so forth before we allow it in our data lake. The data transformation layer is sorted into 3 tiers. That's a fairly common setup. Usually this is called something like bronze, silver, gold. You may be more familiar with that. We use the custom terms raw, refined, and business here. So the raw layer, that'll contain your data, well, in raw format, right? As it is with little to no changes. In the refined layer, we do like basic data curation, maybe some commonly used joins. And the business layer will then contain your highly aggregated data that's like specialized for specific use cases. And finally, we have a data consumption layer that'll contain like everything we need to give it to consumers, right? So database connections, notebooks, dashboards, and the like. There's a couple underlying supporting systems, of course, monitoring, logging, all the boring stuff, and most notably our scheduling system, which is very important to us. I've also sketched our main technology stack here. I won't go into too many details here. So it's all cloud-based. Deutsche Bahn uses AWS. We use Kafka for all things streaming, Apache Spark for all our data transformations. Airflow is our scheduling engine. And we use Hudi for our Lakehouse platform. And I'll say a bit more about that at the end. So Masoud already said we want to highlight 3 of the key challenges. And these are the ones I want to talk about. So data integrity means we need to make sure our data follows certain rules before we allow it in our data lake. And not only does that need to happen in real time at scale, it also needs to be customizable. There might be new data sources, rules might change, and it needs to be customizable by the business experts, not by the developers. So the whole process needs to be user-friendly. Then transformation complexity. The whole data that's being transformed here depends on one another in complex ways, right? We have like a couple hundreds of input sources, and they're all somehow correlated and form complex dependency graphs. And this needs to be transparent and manageable, again, to both the business side and the technical side. And finally, use case evolution. There's lots of people who want our data, and they all seem to want it in slightly different ways. Everyone has slightly different requirements, and so we found that just providing like 1 or 2 standard interfaces just didn't cut it, right? So acceptance just wasn't high enough. So we needed a more custom solution here. So let's look at these 3 in a bit more detail. First of all, let's talk about data integrity. So let's look at this data stream. First of all, we get our data. As I said, it's streaming and it is pushed to us. So other teams needed to integrate the connection to our data lake in their own platforms and products. And that's always a bit of a hurdle because that needs time and manpower, right? And then we sort this into data realms. So what are data realms? So different consumers at Deutsche Bahn will have different requirements on the data. And these requirements can be contradicting sometimes, which makes things a bit difficult, right? Different metadata requirements, different data protection requirements, and so forth. And this is all subject to change. There might be new consumers and so forth. And so these data realms need to be customizable, preferably by business experts. And that's why we created them, to mirror these different kinds of requirements. After we sort them, they need to pass certain quality gates. We might actually change the data a little bit in that. So we check that metadata is present, we check that data protection requirements are met, and so forth. So how did we solve that? First of all, to help other teams interact or integrate with our data lake, we provided them with a standard library. So something we can just hand over to them and say, okay, plug this in, you'll be connected to the data lake. That made it a lot easier for them to connect. A lot less manpower was required. They didn't need to know anything about Kafka and whatnot. And it also helped us to enforce certain standards because the library can just do that for us. You can just make sure that the data they give us maps into a certain format. For both the data realm sorting and the quality gates, we wrote a custom web application, a custom UI for our business experts, where they can view the rules and configure the rules, create new data realms, and so forth. And these rules are not only based on where does my data come from, they're also based on the content of the data, right? So you might have, as a contrived example, you might have a data stream with customer data, and some data realm only wants customer data for corporate customers, another one only wants data for private customers, right? And that might be recognizable by some flag in the data, right? So you can configure your rules based on that. For the quality gates, there's a couple of modes that the business experts can configure. As an example, you might decide to delete certain fields. You might decide to hash certain fields. We also have some AI-powered content detection like tagging or sentiment analysis in this. And then the software underneath this all that actually implements these rules is then, of course, highly parallelizable. I think the official term for this kind of problem is embarrassingly parallel. It's a thing. And so this will scale dynamically as well, so that we can, like during a lull, we use less resources. Because people will travel more usually during the day, we will have a lot more traffic at certain times of day. Okay, next, let's look at data transformation. As Masoud said, we have over 2,000 transformation jobs running a day, and they can be quite different. So some of them may read only like a couple kilobytes, very little data. Some of them may read like tens or hundreds of gigabytes. Some of them may run like every half hour or more often, and some may run like 4 times a year. And they all depend on one another, right? So some raw table will be input for a refined table, and that'll be input for a couple business table, and that forms a graph. And that graph can grow quite complex with new use cases. And that complexity needs to be managed somehow. So first of all, the varying load and granularity, that's where the cloud helps us. So cloud services help us again to scale dynamically and only add compute power when we really need it. So for the dependency complexity, we needed a bit of a different approach. And so what we needed here is that, first of all, the business users could see where their data comes from. They can kind of follow along, okay, how is my data computed? And also we needed a way for the developers to maintain this thing, right? To maintain this complexity. So what we did is we built a smart scheduling library on top of Airflow that was aware of all these dependencies. So it could visualize them, it could document them. It was also integrated with our monitoring, right? So for example, if you have a small hiccup somewhere in the middle of your graph, you can immediately see, oh, these business cases might be affected, right? So you will immediately know, okay, I need to notify these people, or you can automate notifying certain people. Another thing that we noticed, this gets a bit technical, whenever I have one transformation, some node in my graph, that might actually be involved in quite a lot of different use cases if it's a popular set of data. And so any changes I make to that as a developer can have quite a large impact. And the developer might not be aware of all these use cases, and it's quite hard to keep track of that. So what we did is we looked at all the different use cases, and for each use case, we looked at, okay, what are all the tables involved in that? And then we created input and output data that described how we wanted this use case to behave. So we created an end-to-end test for that use case. And now whenever a developer changes a transformation, that transformation has to pass all the end-to-end tests of all the use cases that it is involved in. And that has helped us a lot to maintain, well, code quality, but ultimately data quality. So finally, let's talk about use case evolution. So we've talked a lot about preparing the data. Someone actually needs to make use of it. We have a lot of people that need our data and want our data. And as I said, they all seem to want it in different ways. So we have a data warehouse attached to our data lake. We have pretty dashboards for management level reporting. We have exploratory notebooks, so where data analysts can just rummage around in the data on their own to find interesting correlations or to train their machine learning models. So there's a lot of different ways people use this data lake. And every month they seem to come up with new ways. And as I said, like we found that just providing like these 2 main lanes or these 3 main lanes of connecting to the data lake just wasn't enough. And so we decided to embrace this, and we introduced use case specific applications, or data products as we call them, as first-class citizens in our architecture. Right? So people could come to us and say, okay, if these specific needs, and we could say, okay, we will spin up a new data product for you and integrate this in our architecture, no problem. And I talked earlier about the data realms, and these data products are tightly integrated with these realms. So one data product will run within a specific realm. If 2 data realms happen to have the same use case, we will have 2 instances of this data product, right? So all the compliance rules are met. And I want to talk about one use case that had quite a large impact on our architecture. Very generally, we had a use case where we needed to keep track of golden records of customer data. So normally in the data that we received, we only had change logs of customer data. So we got like, okay, customer X changed their email address or changed their method of payment. But now we actually wanted to keep track of their current state. And that's a common problem. And we found that we couldn't really do this well at scale with the data that we had in a data warehouse. And you couldn't really do it at all in a data lake, because a data lake is really only meant for, adding data, not really updating data. And there's a modern paradigm for that that's really made for that, and that's called the lakehouse pattern. As the name suggests, if you never heard of that, it's a hybrid between data lake and data warehouse. Don't worry if you can't read all the fine print. That's not really crucial. This is like the picture you find if you Google lakehouse from the paper about the paradigm. And the idea is that you still use the infrastructure of the data lake, which has very cheap cloud storage. It has a very open format. And you add a metadata layer that kind of lets you pretend it's a database, right? It gives you transactional capabilities. And with the enormous amount of compute power that the cloud offers, this is actually feasible nowadays. Right, so as you can see here, the traditional setup was you just had like your databases with your very specific database schemes for analytics. Nowadays, what most people do is you have a data lake, and then you have an additional data warehouse for your analytics use cases, and you have all that complicated ETL. And well, the ideal picture is that you only have a data lake, but with the metadata layer, you can pretend it's a data warehouse, basically. And so that was perfect for us. And there's a couple of technologies for that, Delta Lake, Iceberg, Hudi. And after a testing phase, we decided to use Hudi for that. And it integrated quite easily with our architecture, and we implemented that in a couple of sprints. And it has worked quite well for us. All right, so as you can see, there were quite a few challenges that were not easily solvable with standard methods. And I think that with just the right amount of customization, we've solved them well and made the data lake quite future-proof. And with that, I'll hand back to Masoud for the conclusion.
Thanks. So actually, it's the last slide and the last part. So I want to conclude everything with just giving you what this project, the data lake, really add for value for Deutsche Bahn. The most obvious thing, of course, might be in the analytical level, because now Deutsche Bahn is actually able to profoundly understand the data that is available throughout everything that is generated. And they are now able to make smarter decisions, as I already mentioned, on everything related to business decisions, company strategy, company development, and so forth. But beyond this, there are also, of course, benefits for the product itself. As we made it everything custom tailored and as easy to integrate and as possible. Of course, this also helped foster it as a widely accepted product, and it is all widely used throughout Deutsche Bahn in its company. And lastly, of course, this project generated a very large knowledge base of everything. So we kept the architecture and the tooling of the data platform actually as much adaptable as possible, so that we could always react to new demands, new features that had to be integrated, and any changes that would have occurred. So all in all, it was a very successful project, which is highly adapted throughout Deutsche Bahn as a company. And we really hope we just got you involved and interested, and would be very happy to see you in our roundtable.
There's 3 giveaways.